Right, welcome to the ninth lecture of probability and statistics, our course. Last three lectures we have been solving practice problems, right? And they were related to the first three modules that we have done in this course. So, क्या थे हमारे main module? So, याद है? How many did I say we have? So if you remember, I said this course will have 5 modules, right? So if you like 5 topics or 5 main concepts or subtopics that you need to understand to get a good grasp of this field. The first one was assigning probabilities, right? So you talk about uncertain events and then you want to assign probabilities to those. So I have done that in detail. All that we did using sets, counting probability A given B, all that. Yeah, that was assigning probability. So we did a lot on that. Smaller. So assigning probabilities. Yeah. The second module I said was going to be collecting these probabilities, right? And for that we looked at functions. So what were the functions we looked at? We looked at the probability density function, probability distribution function, cumulative distribution, the F, fxy, capital F, all that. So we wanted to efficiently collect these probabilities or the relative likelihoods in functions and then work with those functions, right? So So this was collecting probabilities. Yeah? And here you had the P thing, P A, P B, P all that. Yeah? And here we went from event to variable X and we said, okay, what about Fx, Fxy, Fx given Y? Now, it was all the time still working with probabilities. We were still trying to use them to find probability that this variable lies between this value and that value, right? All those things, we are still working with the probabilities, but it makes this process more efficient. Yeah. Then the third module we did was, we said, okay, for a random event or the related random variable, the probability distributions or these functions contain all the information that we have. But often that information is too much. So we're not always interested in the whole function. We would like to extract some key information from that function that we can work with. And for that, we went to, so this was extracting key info. And we went to the idea of moments, the mean, the variance, and the covariance. Right? And we saw, okay, how can you write these or extract these from these functions? For example, you saw that for a discrete case, the expected value of a random variable x could be extracted from its probability mass function by simply doing this, xi fxi over all xi. Yes? For the continuous case, we saw that the same information could be extracted from the probability density function through an integral and so on. Yeah. Now, before we go to the fourth module, the course has 5 modules. Fourth is getting real, but we will come to that later. Before we go to that, we have to come back to module 2. Okay? And talk about what are some of the most commonly occurring distribution functions. यहाँ तो हमने कुछ भी नहीं, we just said fx will represent this, it will have this property, this is the way you will calculate probability from it, right? It's like saying we will define a class of nonlinear functions, yes, but then do we leave it at that, or do we study nonlinear functions? We do. You have the quadratic, exponential, logarithmic, trigonometric, right? All those. Then you study specific cases of nonlinear functions. See their properties. Why do we do that? Because they are commonly occurring functions in our mathematical modeling. Why does it help to work with commonly occurring functions? Because see, if people have developed some tools to solve problems in trigonometry, and you realize that your problem can be written in trigonometry, then all the tools, all the proofs, all the numerical methods available in trigonometry are now available to you, right? So once you are able to classify where does my problem fall, you can use all the knowledge that has already been developed, and maybe if your problem is so new, you may end up developing new knowledge. Yeah. Similarly here, for the distribution functions, this PDF, CDF, joint PDF, PMF, together they have one name called distribution functions. Okay, फिर अंदर उसकी categories होती हैं. But basically distribution, what do we mean by distribution? We mean how is the probability of the variable distributed? कहाँ पे कितनी है? Yeah, that's why we call it distribution. So now what we would like to see is, well, people have been working with probability, they have been working with uncertainties, they have been working with distribution functions. What are the functions that most often show up? Okay, just like in nonlinearity, what nonlinear function, what are the functions that most often show up? Quadratic, logarithmic, sinusoidal, trigonometric, yeah. और भी एडवांस भी है लेकिन कम आते हैं ना, इसलिए आपने अभी तक उससे अगले शायद नहीं पढ़े होंगे. So we will, for as a first course, we will actually now come back to this module and complete it. What the reason I didn't complete it before was that when we study different common distribution functions, in each case we will discuss their key information. What is their key information? Mean and variance. So I had to give you that concept before coming back here, right? So now we are ready. We know what we mean by these guys, hopefully. So now we will talk about, or now if we talk about some common distribution functions, I will along with that immediately tell you, okay, this is the mean and variance of this function. Yeah, and you will know what that means. Yeah. So let's do that now. So we are back to second module, next to this lecture and probably the next one, 2 lectures on the more data for more knowledge on the second module. Right, so yeah. So as I said, we looked at the probability distribution functions. For example, we saw for the discrete case that is represented probability x equals x. It had some properties, we worked with it, we did a lot of things, extracted mean and variance from it, as I've already mentioned. Now we are interested in seeing, okay, what are some of the common distributions that show up, and in that our goal will be to look at these, how many? 5? 1, 2, 3, 4, 5. Yeah. Now they are by far not the only ones. Okay, huge number. Nonlinear function भी आपका है सिर्फ cosine वगैरह तो नहीं है, big list. Yeah. But when in a first course we have to restrict ourselves to the most common ones. Yes. So in that we will be looking at uniform distribution, binomial, geometric, negative binomial, Poisson distribution. What does each of these mean? It means what shape is fx taking, what shape or what function is fx, your distribution function, taking. What यहाँ क्या आता है इसकी? What do you put here? What do you put here? Is it exponential? Is it constant? What is it? And of course, based on that, if you draw that out, each one will have its own shape. So we are interested in seeing, okay, now what common functions are there, and in doing so, we will also talk about when do those functions show up reality. Yeah, so we've already seen, and this lecture we will restrict ourselves mostly to discrete case. So these 1, 2, 3, 4, 5 are for the discrete case. Discrete case, yaad hai, what is discrete random variable? When x takes a discrete set of values, continuous nahi hai. Yeah, so it could be in countably infinite, or it could be finite number of values. Rolling a die, the value that shows up, how many possible? 6 values. So that's a discrete set. Yes. So all of these we do for discrete case, and let's start with the uniform distribution. Now the example of rolling a die again. इसकी क्या distribution बनती है? Firstly, how do we write the distribution? If you remember, we did some exercises and we said, okay, if case of a rolling a die, first you identify what are the possible values. That x is showing the rolling a die. The possible values are x1, x2, x3, x4, x5, x6, and these are 1, 2, 3, 4, 5, 6. Rolling a die. Yही possible values है. Yes. So what you do, if you plot it out along x1, which in case of rolling a die is actually 1. Yes, 1 showing up. x2 and so on up to x6, 3, 4, 5, 6. What's the probability that this is 1, 2, 3, 4, 5, 6. What's the probability that a 1 shows up? We have done that many times. What is it? 1 by 6. Now if you plot it, what do you see? It will be here. Yes, the height will be 1 by 6. Yes. What about the probability of a 2? Again 1 by 6, 1 by 6, 1 by 6, 1 by 6. Just look at this plot. Is it uniform or is it changing? Uniform. Yes. So basically uniform distribution is the mathematical function where the discrete set of possibilities are equally likely. Okay. So if you are dealing with a probabilistic problem where all the possible outcomes in the sample space have equal chances. We're not saying what those chances are. They could be 1 by 6 each, 1 by 5 each, yeah, depending on what outcomes are there. But as long as they are equal, uniform, no changes, we call it, or we say that this random variable has a uniform distribution, right? And as you can guess, what we write it as is basically if it is taking a value, a fixed value, let's say k, yes, for all possible values of x equals x1, x2, x3, whatever possible values are there, on all those values it takes the same or assigns same probability to them, and 0 otherwise. Yeah. So you could ask me, in rolling a die, what are the chances of getting a 1.5? I can answer that. That is 0. Right? So the function is actually, in a way, it is continuous, the function, because I can give you, it is 0. Now, not strictly continuous because there will be jumps here. Anyway, you could ask me for what's the probability of having a 7. Yeah, that would be 0. What we are interested in is this part. All the possibilities are equally likely, same probability. So that is among the most common distribution that you see. What else has a uniform distribution? Tossing a coin. The probability of heads and the probability of tails is what? Both are 1 by 2, 1 by 2. So uniform distribution often shows up in many situations. Okay, and to summarize, if you are dealing with a situation where among a set of possibilities all are equally likely, yeah, let's say I am going to pick a number from 1 to 100 randomly in my head, yes, so there is no reason to think that I will always pick 5 or 6 or, yeah, so in that case they are all equally likely, yes, and what is the likelihood of each one if I have to pick randomly from 1 to 100? 1 by 100. So the k value doesn't matter. It's the fact that it is fixed that matters. Yeah. So rolling a die, all that makes sense. And in physics and in many mechanical systems, uniform distribution naturally shows up. Okay, some things have equal probability of taking a particular temperature within a range. Okay, you will not have information about if it is more likely or less, so you will have to assign uniform distribution. This is what you do, rolling a die. Now in each case, we will be writing the distributions as functions and drawing their figure. Yeah. So for the case of rolling a die, it's this one, only 6 possibilities, and on those 6 possibilities the probability is exactly the same. There is no x value here, so it isn't affected by this, but of course you have to make sure that this applies only to these values. All other values get probability 0. Yeah, so all the possible outcomes are equally likely, and you have this thing. What is the mean of this one, by the way? Mean yaad hai? We did several interpretations of it. We did the interpretation of expected worth. We did the interpretation of center of mass of the distribution. Where should you place the edge so that the distribution weights and the force they apply is balanced? So iski average value kya hogi? 3.5, right? So if you put the wedge here, you can already imagine that this is balanced, right? थोड़ा सा left करेंगे तो right को गिर जाएगा, थोड़ा सा right करेंगे तो left को गिर जाएगा. Now you know the average you do. If I give you 3 numbers, 10, 5, 15, and you have to do average, how do you do it? You add, divide by 3. You know what you are doing? You are saying, okay, you just gave me 3 numbers, you didn't give me their probabilities, so you know what you do? You assign them equal probability. 3 number hai, 1 by 3, right? So basically you are saying, okay, you gave me 3 numbers, let's say 5, 10 and 15. So 5 plus 10 plus 15 divided by 3. Actually you are saying 5 has a probability of 1 by 3 plus 10 has a probability of 1 by 3 plus 15 has a probability of 1 by 3. This is how we write our mean. Remember, discrete case mein expected value of x is x times fx. So you are all the time using uniform distribution in calculating averages. Yeah. Now if you don't have any other information about something, this makes sense. But if I tell you that 5 is twice as likely as 10 and 15, then if you do this again, it would be incorrect. Yeah? Then you will have to assign 5 a double probability compared to the other 2. Yeah? And then see the sum. Why does this approach work? It actually works in large numbers actually. Here we are saying I don't have any information, what can I do? You just gave me 3 numbers and said find the average. Yeah. So then I will just assign equal probability to each of them. I will assign a uniform distribution to them. Right. But it also makes sense. If this number of values I give you becomes larger, then it will make sense. It is a bit digression from here, but notice, what if I tell you 4 numbers, 5, 5, 10, 15? Find their average. Divide by? Not 3. Yes? 4, right? So why not divide by 3? You have 4 numbers. But notice what you did. You said, okay, I will do 5 plus 5 plus 10 plus 15, and I will divide it by 4. That's what you did? Yes? But notice, by assigning equal probability to each of these, you actually assign double probability to 5. Right? Why is that? Well, 5 appears twice, so you're saying 5 has a probability of 2 by 4. That is 5 plus 5, which is 5 times 2, 10, plus 10 has a probability of how much? 1 by 4, plus 15 has a probability of 1 by 4. Are they the same? Exactly same. But now you have doubled the probability of, इसकी probability क्या है? 1 by 2. इनकी क्या है? Quarter. Half is a double of quarter, isn't it? So you have actually doubled the probability. So the idea that जो हम use करते हैं ना average करने का, it makes sense if you have large data, because then automatically it will increase the likelihood of those values that show up more often, right? So there's a bit of digression, but essentially this is the uniform distribution, easily the most simple and easiest distribution, right? Which is, if you see its graph, it's a, if it's continuous, it's a straight line. If it is discrete, it is values of same level. Yeah. Okay. So in fact, if for any set of, that was for die, right? Rolling a die, 6 possible. But what if there is a discrete random variable that has n possible outcomes, and all of them are equally likely, right? Then what is f of x? F of x is, in this case, no, the probability, so for each of these is 1 by n, right? N possible outcomes, all are equally likely, so then they have to be 1 by n. ये आप कहते हैं ना, die में 6 possibilities, all equally likely, so each is 1 by 6. So n is 6 there. So, but then you have to make sure that this result holds for the allowed values. It's a discrete variable, right? So it's only for the allowed values, whatever they are. For all other values, of course, otherwise you assign a probability 0. Yeah. So in general, this is how the this is the general formulation of a discrete uniform distribution, right? So n possible outcomes, all equally likely. If that is the case, then your random variable x will follow this distribution. Okay, right. So mean and variance of a uniform distributed random variable, well, from the definition you can see that it will be 1 over n summation x I. Yeah, and this is what you do when you find the average. कोई भी number हम आपको देते हैं, you do that. ठीक करते हैं ना उन सबको, you sum them and divide by how many they were. So you are actually always assuming uniform distribution on them. Yeah, and the variance formula. This is a useful result. It says that, I won't prove it here, you can actually do it, calculations on your own and see, it's not too hard. It's saying that if x takes discrete variables on consecutive integers, right? In this example, there's no requirement that this is 1, 2, 3, 4, 5, 6. No, this could be 1, 3000 million. All it's saying is there are n possible outcomes, all are equally likely. All this is the only thing it's saying, right? It's not saying that they have to be in order. Yeah, they don't even have to be integers. It could be x1 1.5, x2 could be 10.5, x. They could be unequally spaced. Fine, as long as there are n discrete possible outcomes and all are equally likely, this formula holds. Yes, this whole thing holds. But there is a special case where these values are consecutive integers from a to b. So if they are consecutive integers from a to b, we are saying is that you start here maybe at 4, that is your a, and then you have a plus 1, a plus 2, that is 5, 6, if you want to put some value just to get a feeling, and then it goes all the way up to a bigger number b. B has to be greater than a for this formulation to make sense. If they are consecutive, तो समझ गया ना, यानी कोई skipped नहीं है, and integers from a to b. In case of rolling a die, are they consecutive integers? The possibilities. क्या है possibilities? 1, 2, 3, 4, 5, 6. Are they consecutive integers? Yes. What is the a? A क्या है? 1. B क्या है?
2, 6.
6 है ना? So here now we are going to write the general case for that. Yeah. So it is a to b consecutive integers. If that, this is most general, but from here, if this case happens, then actually the mean and variance becomes simpler to calculate. Remember I said we are coming from the third module, which was about mean variance, to the second module, because whenever we talk about now a distribution, we will talk about its key information. Key information, mean variance, and in some cases covariance if it's a joint distribution. Otherwise single distribution only has mean variance. So the result is that if you have a situation like that, then the mean is simply the middle point. That's it. B plus A divided by. You don't even have to do this whole exercise of summing them all up and divide. If they are consecutive integers from A to B, just take their middle point. That's it. So A plus B, middle point means the first value plus this last value divided by 2, and you have it. The variance comes out to be a bit more involved, but it's not mathematically, it's not hard. Your book will have the proof, I think. You can check. They will derive from here, starting with a plus 1, a plus 2, up to whatever b. B would be a plus b minus a plus 1. थोड़ा सा वो numbers का juggling करनी पड़ती है, but it's not rocket science. So this results, yes, very useful, very powerful, both काम आसान हो जाता है. But when does it hold? Consecutive integers that have uniform distribution. ऐसे नहीं consecutive integers का distribution ऊपर नीचे है, कोई ज़्यादा likely है, कोई कम likely है. Don't apply this. Yes, you always have to know कि जो आप the result you are applying, does it satisfy the assumptions for which it was derived? बाकी तो फिर वो गलत हो जाएगा. Okay. So yes, you can check from that formula for the आपने बताया था ना मुझे 3.5 for the die rolling. So A is 1, B is 6. Yes, 6 plus 1 by 2 is 3.5. A plus B by 2. Yes, and even this thing. Now you don't have to do that lengthy formula for variance. Yes, sum all those values. You just need to put the value of B and A here and get the variance directly. That's the power of defining common distributions or common things. Yes, you can define them, you can classify them, then you can develop results and tools for them that make work very faster instead of doing this dumb work again and again. So now we go to the more interesting way. This I think is just too easy, uniform distribution. Yeah, so nothing to talk about there. So the real interesting part starts here. these three distributions, binomial, geometric, negative binomial, they are based on something called Bernoulli trials. Okay, so all three come from a kind of experiments that represent a lot of real world situations, and they would be called Bernoulli trials. So first we define Bernoulli trials, and then we see you will ask three different questions on the Bernoulli trials, and each question's answer will lead to a different distribution. Okay, so let's ask those questions. Like I've been asking, what's the height of the next student coming in? Yeah, that's one question I've been asked. But what if I ask how much time between two next students coming in? कितने फासला होगा? Interval कितना होगा? Right? I change the question. Yeah. Okay. What's the probability that the next student shows up in next 5 minutes? I change the question. Same event, same thing happening, but you're changing the questions. Depending on the questions, the distributions would change. They may not change in some cases, but in general, it is expected they will change. Now, I developed this for my students in Saudi Arabia because it's very common there to have a car from an early age and have a lot of time and big roads. I don't know if it applies here, but you will get the idea. So I used to tell them, you have Mercedes, mashallah, very good, and you have a coin and lots of time. So you one day decide to do this interesting exercise that you start driving, and every time you reach a fork or two options, yeah, right or left, how you decide is you toss a coin and see if there is a heads, yeah, you go take the left side. If there is a tails, you take the right side. Okay. Now, the probability that you take left side, let's call it P. Okay. In case of tossing a coin, P is 1/2, isn't it? Yeah. And the probability that you take the right side is, we will call it Q. Okay. And that will be, in case of tossing a coin, it will be 1/2 also. But in general, in Bernoulli trials, P and Q do not have to be equal. It is just that you have, in Bernoulli trials, always you have two choices or two things that will happen. Thing will fail or not fail. You will come or not come. You will go right or left. Yeah. So these are the situations where you are dealing with two possible outcomes. Okay. And one has probability P, which could be more than the other. In this case, in this example, they are saying the other has probability Q. How are P and Q related? Can somebody tell me? Can I write Q in terms of P? Q is 1 minus P. दो ही option है. Q plus P has to be 1. So Q is 1 minus P, or P is 1 minus Q, however you like. So in later developments, the formulas we will skip Q and just use P. क्योंकि फायदा नहीं है एक extra variable डालने का. Then you know that it has to be 1 minus P. So anyway, now the interesting thing is that once you have taken one of the tracks, at the next juncture, yeah, you repeat this exact same thing. What is the exact same thing? That you do the same random thing, that you toss a coin and you take left with the same probability that you originally applied to left. So again, left की P हमेशा change. If you change it, then it's no longer a Bernoulli trial. This is the setup we're doing. Yeah. So in each case, the probability of taking left is same, which is a value P. अगर वो 1/3 थी, पहले टर्न पे अगर लेफ्ट की प्रोबेबिलिटी 1/3 थी, तो फिर दूसरे में भी 1/3 रहे, तीसरे में. These are the conditions required for a Bernoulli experiment. Right. Similarly, the probabilities of taking a right are always remaining the same, Q. So ये important. This is. So what are the things coming out? It seems like there is a repetition of the same thing. That's one thing, repetition. Yes. Second, in each repetition, the two possible outcomes, outcome A and B, always happen with same probability, not equal. I mean, so if A happens with probability 1 by 3, then it keeps happening with probability 1 by 3. If B happens with probability 2 by 3, it keeps happening. Not that in one repetition it is 1 by 3, here it is 1 by 4. If it is changing, it's not good. The third thing that I haven't mentioned yet, if that condition is also satisfied, then we are talking about Bernoulli trials. The third requirement is that your decision at each juncture. So you will make a decision where? One decision here. फिर कहाँ decision करना है? Somewhere here, here, either. So your decision at each juncture is independent of your decisions before or after. Okay? इस केस में वो satisfy हो रही है condition. Coin toss करते हैं आप हर दफा. Result of tossing a coin is always independent of the previous toss or the next toss. कोई उसकी dependence नहीं होती ना. So this example satisfies that condition, but that is the general condition. So repetition of the same thing. Firstly, two possible outcomes, that is important. Repetition of the same thing, then keeping the probability of each outcome, whatever it is, remain consistent, don't change it. Thirdly or fourthly, if you want to count this is important. Fourthly, they are independent. Each time the decision is independent. So if you satisfy that kind of condition, we say that you are dealing with a Bernoulli experiment or Bernoulli trial. Okay, trial is often people write it in terms of success or failure. So you will do something, you succeed with probability P, you fail with probability Q, and you try many times, right? And each time the outcomes are independent of the previous ones. Yeah. So now that was just the setup. Of course, what are the possible outcomes here? You can see that. Yeah. यही है ना, तीन कितनी repetitions हुई हैं? 1, 2, 3. Yes. So we will later see that we have a name or something for it. The letter N we use for that. So there are 3 repetitions. Yes. And now you see how many possibilities you have. LLL, LLR, RR. Like 9 different places you could be. 9 and 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay, 2 to power 3 basically. Yeah. So I've already explained that. We need to do that. Now, an experiment that satisfies the conditions we just saw, we call it a Bernoulli process, and each repetition in it is called a Bernoulli trial. Okay, an attempt, whether you fail or pass. If you have lots of resistors in a lab and you randomly pick one, and the probability of a resistor being faulty and not faulty remains the same, whatever they are, and then you pick 1, 2, 3. First one you try, success or failure, works, not works. You take a second one, works, not works. So if they satisfy all these conditions, we will call that a Bernoulli process, and it's each your attempt is a Bernoulli trial. Yeah. So again we did that. Now, as I said about the student coming in, I could ask many different questions. Yes. So for Bernoulli trials, once you have set up that those assumptions, you could ask many questions, like what is the probability that in n repetitions you take exactly x left turns? For example, the car key. Yeah. So how many are there? 3 repetitions. 3 dafa hua tha. So what is the probability that you take exactly x? Means you can put a number there. What is the probability that you take exactly 2 left turns in 3 attempts or 3 repetitions? So any question you might want. Another question. What is the probability that the first left turn you take is at repetition number x. Yeah. Now in terms of this example was just made to make things interesting, but in terms of picking this resistor from the pile, yeah, the question would be, what is the probability that if you take 10 resistors, exactly 6 of them are faulty? That's the first question in that case. Yeah. Second question, what is the probability that you have to take 6 or the 6th one will work, the first 5 will be defective? That's the second question, right? Now, another question, what is the probability that it takes you x repetitions to take exactly r left turns? So this would be like saying, what's the probability that you will need to take 10 resistors for 6 of them to work? Yeah. So you can already imagine, actually this formulation is very powerful. It shows up a lot in random sampling, in testing, in working with things. Okay. So now the thing is, each of these will lead to, and there are more questions by the way. मैं सारे डालेंगे क्योंकि I don't want to cover all the distributions of this. So each will lead to binomial geometric negative binomial. So they will lead to different distributions, and that's what we want to see today. So first question then, कितनी repetitions हैं इस case में? 3. Yes. So I'll just put that out here. N is 3 repetitions. 1, 2, 3. But आपने सारे काम तो नहीं करने. I'll get here, then repeat second time, then repeat third time. Yeah. 1 of 3 है. So what's the question? What is the probability that you take 3 left turns? And I will written that in 3 trials. 3 दफा आपको decision मिला, right? So I wrote n equal to 3. So कैसे होगा? क्या होगी? Mathematically, how do we write it now? नहीं, अभी जवाब नहीं देना उसका. वो इस केस में ज़ाहिर है, you are looking at 8 equally likely possibilities, right? So the probability is 1 by 8 for that. But it won't always be the case. Here it will work because P and Q are equal. If they are not equal, फिर आप 1 by 8 नहीं कर सकते, right? Why? Because if P is larger, let's say P is 2 by 3 and Q is 1 by 3, then this person is more likely to take left turns, right? So then the idea of equally likely won't apply. So first let's write it out mathematically and see what happens. Is that correct? The original question, what is the probability that you take 3 left turns? I can write it as probability first left and second left and third left. ऐसे ही है, हमने पढ़ा था start में and or, yes, not. So remember what I've been saying in solving problems, always assign events, this formula, these variables. So let's say T1 means first turn, T2 means second turn, T3 means third turn. Then this can be rewritten mathematically now. What is it saying? Probability T1 equals L and T2 equals L and T3 equals L. That's what we're asking for. Yes? Can somebody tell me what this will be? The formula. If I can I expand this formula? Can I do something with it? Not the value. You have a key information. Remember, Bernoulli trials assume each trial is independent. Yeah? So if you remember, we have been talking about independence, saying that if A and B are independent, then probability A and B can be written how? Yes? It's separable. We've been talking about that. So Same goes for 3. Probability A and B and C is probability A times probability B times probability C. If they are not independent, no way you can do this. Okay, this only works if they are independent. Now I know by my setup of the Bernoulli experiments, they always assume independence between trials. So these three are independent. The problem becomes easier. What can I write it as? It will be probability T1 equals L times probability T2 equals L times probability T3 equals L. Now all of a sudden it becomes very easy. What's the probability that the first term will be left in this case? 1 by 2, or in general P? Yes? P? Okay. What's the probability that the second term will be left? P? Yes? What's the probability that the third term will be left? Also P. हमने कहा था ना रिक्वायरमेंट है चेंज नहीं होनी चाहिए, जो भी है वही चलेगी. 1/3 है तो 1/3 चलेगी. Yeah? So P. So basically you have answered the question. The probability that you take 3 left turns is P Q. Okay. Now if P, as you said, was 1 by 8, because in our case P was 1 by 2. 1 by 2 cube is 1 by 8. There it works. But if P is not 1 by 2, you cannot just count and say it's 1 out of 8 possibilities, right? So what just happened is that the independence assumption helped you separate them, and you were able to calculate it. Yeah. So let's see now. Yeah, makes sense. Now, second question. We will come back to the first one also. Yeah? What is the probability that you take exactly 2 left turns? Again, the assumption or the thing that I should write here is that in n equal to 3 trials. Yeah. So you try do 3 repetitions, and what is the probability that you take exactly 2 left turns? So yeah. So firstly, of course, these are the 3 outcomes. If P and Q are equal, then all are equally likely, and you could say 3 by 8. Yeah. But if P and Q are not equal, the general case, then that would be wrong. So we have to develop it. आपने क्या कहा? PPQ. Let's see if you're right. Again, what would be our attacking strategy? Probability that you take exactly 2 left turns. If I wanted to write it in probability, how would it be? Because that T1 should be what? T1 should be
left.
Okay.
Intersection T2 equal to and left.
Left. Okay. And
intersection T3 equal to right.
yes. Why? Because it's exactly 2 left. Is that all?
Yes.
सोच लें.
इसको खोल लें.
नहीं अभी ये पूरा नहीं हुआ. आपके सामने आपने मुझे एक लिखवाया. नहीं? Or. Yes. And they are mutually exclusive. आप इन सब जगहों पे तो नहीं पहुंच सकते. एक पे ही पहुंचना. Mutually exclusive है. So I can replace the or, which is the union, by a plus. याद आ रहा है वो शुरू में जब मिल गया. I can put a plus. Plus for us is meaning here or for mutually exclusive. Probability A union B is probability A plus probability B minus probability A intersection B. Unless they are mutually exclusive, then the third term disappears. Yeah, so this is what's happening. अब बताएं probability क्या? T1 equals left.
Intersection T2 equal to right.
Right.
Intersection T3 equal to left.
Yes. So this is also exactly 2 lefts. And then the third one RLL. Yes. पहला right लिया फिर left left. Yeah. So आप बताएं PPQ है या कुछ और है?
Plus.
Now again, so there is a third one here, and each one is again independent. So you can again separate them. Yeah, so this becomes P P Q जो आपने बताया, but then you missed plus क्या हुआ P Q P something and then Q P P, but all of these are basically P square Q, isn't it? Yeah, so it's 3 P square Q, है ना? Good. ये मैं आपको इसलिए बता रहा हूँ क्योंकि जब एक्चुअल फॉर्मूला आएगा ना अभी वो थोड़ा सा बड़ा होता है, तो यू विल बी लाइक ओ माय गॉड ये कहाँ से आया, कहीं से नहीं आया, यहीं से आया. Okay, they just develop these things and just show you the final result. So more questions like this, and then we go to yeah, as I said, these three, and now we are at the three distributions. We will come back to what you just did, but essentially this is what's happening. Binomial distribution. If you ask, you will ask 3 different questions on Bernoulli trials and you'll get 3 different distributions. That is a Bernoulli thing. Now from here on, which is more common in literature, in books, left turn is success, right turn is failure. Okay, common, otherwise it just means option A, option B. That doesn't mean anything else. So if you ask the question, if you say, okay, X is the number of successes in n Bernoulli trials, yeah, like I said in the first question, what is the probability that you take 3 left turns? Yeah, so 3 successes. You want to find, if you say X is 5, what are you saying? You're saying, what is the probability that there are 5 successes in n, and let's say you try 10 times, so in 10 trials. That's the question you're asking. If you say X is 2, you're saying what? 2 successes in 10 trials. If you say X is 0, what are you saying? No success in 10 trials. 10 की 10 fail हो जाएगी. Yeah? In our case, that would mean no left turn in 10 repetitions, right? So the probability distribution then follows this formula. ये वो NCR है, n factorial over n minus r factorial. Yeah. So remember this P, ये Q. Yeah. I will come back to this. And actually, this is what you just solved for a special case. Okay. But we will come back to it. The important part I want to say is that when you ask this kind of a question on Bernoulli trial, or X represents the number of successes in n Bernoulli trials, then X has a distribution that follows this formula, and we have a name for that formula. We call it the binomial distribution. Uniform थी ना, easy थी. अब इस तक होने में थोड़ी सा headache हुआ, अभी Poisson आएगा तो और मजा आएगा, right? But once you grasp them, it's not magic. They make sense. What if you change the question? So the setup is same. You change the question. You say X is number of trials till first success. Okay. What is it saying? If X is 5, what do I mean? If X is 5, that means if you are picking up ICs, that means that the 5th IC is the first one that works. First 4 fail. Yeah. Number of trials till first success. And this is often important in real life problems when scientists try to study the likelihood of something happening. If your question is this, then X will follow a slightly different formula. कुछ फर्क नजर आ रहा है ना, different, yeah? We'll come to that. And this formula will be called geometric distribution. Now notice, here it was X had values 0 to n. Yeah, because you cannot ask me that what is the probability of 15 successes in 10 trials. 10 मैंने ICs उठाई हैं और उनमें से 15 काम करें, नहीं हो सकता, 0 ही होगी उसकी probability. So that's why you limit X to maximum trials. उससे ज़्यादा तो possible नहीं. इधर हमने उसकी कोई बात ही नहीं की कितने trials हैं, right? You could be trying millions or thousands of ICs, and 1001 IC works first time. Yeah? So इसलिए this goes on. Yeah? There's nothing to memorize basically. They all make logical sense once you fully grasp what's going on. So we call this the geometric distribution. इनके नामों के पीछे कुछ reasons हैं. They're not always linked to probability theory. बस ऐसे geometric function या उससे binomial function, I don't know आपने पढ़ा होगा maybe basic binomial. So it's kind of those things. Okay. Now let's change the question. Number of trials till R successes. This was saying number of trials till first success. This is saying number of trials till R. What do we mean that? If X is 6, what are we saying? And let's say R is 3. Then we're saying that what's the probability that it will take me 6 trials to get 3 successes? Or it will take me 6 ICs to get 3 working? Question change ho gaya? Yeah? So the answer will have a different probability. It looks like this, and this is called the negative binomial distribution. Notice what happens to X. क्या हो गया इसका? R plus 1 क्यों? R minus 1 क्यों नहीं हो सकता? You're asking me how many trials for R successes? फिर at least R trials तो आपको करनी चाहिए ना? Yeah. You're asking question, okay, how many ICs I need to check for 10 of them to work? और आप check सिर्फ 9 करें तो जवाब तो नहीं बनेगा. Yeah. So that will be 0. Remember, always remember, when we write this function and we write this value, we are saying that all other values are allowed, but they will have probability 0. Yeah. So आपको पहला सवाल हम पूछ सकते हैं कि 4 ICs उठाए हैं और 10 काम करें, आपने उसकी probability क्या है? 0 है, right? So you don't need to mention it here. So everything else is impossible. Okay, and the NCR thing. Now let's do the interpretation of each of them. पहला सवाल था हमारा, क्या था? Number of successes in n trials. So if you're saying what's probability that X equals 5 in say n is 10, you're saying 5 successes in 10 trials. So X represents the number of successes. So does this make sense? Now if X takes the value small x firstly, right? If X takes the value, this is what it is saying, you know this, yeah? This is probability X equals small x, yeah? Yeah. Function. So let's say this is 4 and this is 10. Okay, so you're saying what's the probability that there will be 4 successes in 10 trials? Yeah. Now, if you're asking about general X from this range, बाकियों का फायदा नहीं पूछने का, वो impossible है. Yeah. So, how many successes will you have? If you're asking what's the probability of X successes, then you're talking about X successes. Yes. So they are all independent, so it is P to X. Right? And now you ask, okay, बाकी साथ क्या हुआ? Trial आपने कितने किए? N. Right? What happened in the rest? Did you succeed or fail? Fail है ना? अगर नहीं fail हुए होते तो फिर X successes तो ना होती हैं, X plus 1 होती हैं, X plus 2 हो जाती, right? If you say I have X successes, then you have X successes, then N minus X, the remaining trials were a failure, right? So failure का याद हो जाए तो दूसरा option था उसकी probability Q थी, which is 1 minus P. So this is your failure. कितनी दफा होगा failure? N minus X times. And each one of those are independent, so you can simply write them as powers and products. Where did this come from? Remember, we said 2 left turns, yeah, in 3 trials, 3 with 2 left. तो क्या निकला था? LLR, LRL, with combinations भी आ गए. Right? How many ways can you choose 2 L's from L and R in 3 positions? तो 3 तरीके थे उसको. So of course you have to say, okay, how many ways can I choose X successes in N trials? How many ways are there? क्या? क्योंकि इसमें ये नहीं कहा गया कि आपने पहला, चौथा और पांचवा पास किया, या आपने पहला, दूसरा और तीसरा पास. It doesn't say. It says there's 3 passes in 10 trials. That's it. Yeah. So then you have to allow for all those possibilities. वो जो मैंने plus करके नहीं लिखे थे दो. Yeah. So this guy is representing that. So the whole formula makes sense. इसमें कुछ है ही नहीं. Yeah. X successes, yes, probability of each success P, they are independent, so you can just P X times, so it's Px. The remaining must be failures, so there are n minus X of them, minus P. And you have to make sure that the combinations are taken care of, so and choose X. So, yeah, so I just explained that, written it here also. Let's apply it here. Remember this, you just found 3p square q tha no? So I just replaced it by 1 minus p, so it links with the formula. Confused now. So here I replaced q by 1 minus p every time. And left I replaced with success, failure, and so on. Yeah. Now, notice. You could directly say, okay, what is the probability of getting 2 successes in 3 trials? Well, just put the values here, 3, 2. You will solve it and reach exactly the same conclusion that you reached before. 3p square q, 2 lefts in 3 trials. Yes? So 2 successes in 3 trials. Now, this was the second question that led to geometric distribution, was number of trials till first success. So if X is 5, what are we saying? What is the probability that it takes 5 trials to get first success? पहले 4 क्या होंगे फिर? फेल होने चाहिए, वरना तो आप पहले ही पास हो. So now does this make sense? कितनी successes हुई हैं आपकी?
पहले एक
इसमें ट्रायल्स कितने होंगे बाय द
वे?
X trials only, right? Because as soon as you have that first success, you stop. Right? So इसमें n नहीं है. Yeah? The other variable is gone. Binomial. उधर 2 variable थे, n और x. इधर नहीं है, single. तो उसकी geometric distribution. Even the name starts showing up. Yeah. So basically you will do X trials. Yeah. What happens? First one fails, second one fails, first one fails, second one fails, third one fails, up to X minus 1 fails, and the Xth one passes. क्या लिख सकते?
1 minus p को
क्या लिख सकते? Q. हाँ लिख सकते हैं आप. The thing is फिर आपको कहीं separately लिखना पड़ेगा, because in Bernoulli trials this information is there that there are only 2 possibilities, right? So if you just write it like this, then you just get rid of that extra information. When आपको separate, let's say I write it as Q, yeah, Q X minus 1 times P. And somewhere I will have to write that Q plus P is 1. हर दफा लिखना पड़ेगा ना मुझे, तो फॉर्मूले बड़े होते जाएंगे. Why not? Occam's razor का सुना आपने? Occam's razor, philosophical concept है, read about it. It says that do not complicate things more than they need to be, right? So, or another way of saying it in mathematics is the number of parameters shall be kept so that the minimum number that suffices this description. तो आप एक पैरामीटर मिला हो जाए नया ला रहे हैं Q, right? जबकि हमें पता है कि Q plus P is 1. Why not integrate that information in one formula, right? So बस वो it's a matter, उसमें कोई मसला नहीं है. You could write it like this, but then somewhere you will again have to write b plus q is 1, right? हर दफा लिखना पड़ेगा. But now the key thing here is up to here failures, so x minus 1 failures, here it is, and 1 success. Yeah, so ये उसका formula is there. And this was the, let's say, probability of but if we want to see, okay, what is probability that the first success occurs in 3 trials. Yeah, so that is FFS, and you can check that it will be 1 minus b squared b. Try from this formula, same answer. Yeah. So makes sense. Third one, what if your question is number of trials still are successive? What it's saying, it's if x is 3 and r is 5, oh sorry, it can't be more than, so if x is 5 and r is 3, you're saying what's the probability that it will take me 5 trials to get 3 successes? Yes? So here is the negative binomial distribution. Again, 2 variables here. Yeah, and what happens now? कोई explain कर सकता है ये क्या है? इस पे बाद में आते हैं. इधर क्या हो रहा है? ऐसे क्यों है? P R 1 minus P x minus R.
वो हम इस पे वो प्रॉपर्टी निकाल रहे कि अगर हम एक स्पेसिफिक अमाउंट ऑफ ट्रायल्स दें और उसमें इतने सक्सेसेस हो जाए, तो जितने ट्रायल्स होंगे उसमें से अगर हम सक्सेसेस माइनस कर दें तो हमारे पास टोटल नंबर ऑफ फेलियर्स आ जाएगी जो कि x माइनस r है और हमारे पास p है और जितने सक्सेसेस है वो p की पावर हो जाएगी.
Right. So how many trials in this case? R successes. How many trials? X. X is the number of trials. जो ही आपकी R successes पूरी हो जाएगी, आप रुक जाएंगे, right? So let's say I'm saying 3 successes in 5 trials. Yeah. If X is 5 basically, then I'm saying 3 and R is 3 successes in 5 trials. तो फिर तीसरी सक्सेस किस ट्रायल में होनी चाहिए? पहले तो टोटल 5 ही ट्रायल हुए आपके, राइट? तीसरी सक्सेस किस ट्रायल में हुई? फिफ्थ में. और उससे पहले हो गई तो your x is not 5 now. Yes, and it cannot be less than 3 because 3 तो है, तो it has to be r plus 1. Yeah, so you're right. There are x trials, x minus r of them have to fail, r have to pass, right? But now if anybody can explain this, that would be amazing. ये क्या कर रहा है? बाइनोमियल में याद है हमारा था n x, number of successes, let's say 5 successes in 15 trials. So we said we have to see, okay, how they are, the successes can be spread out. Yeah, but ये तो बड़ा difference है ना? क्या है, कैसे? Total trials कितने हैं? x. ये x minus 1 क्यों है फिर? टोटल ट्रायल्स x है ना, तो ऐसा लगता है कि कॉम्बिनेशन में x होना चाहिए. या इट मेक सेंस.
R सक्सेसेस से एक पहले खत्म हो जाती है,
खत्म हो जाती है.
नंबर ऑफ ट्रायल्स टिल R सक्सेस.
हाँ, नहीं आर वो x तक तो आप जाएंगे, R सक्सेस आएगी उसमें. सो थोड़ा सा सोचे, कोई कुछ करके देखें ना, ज़हन में कोई नंबर बनाए, ट्रायल करना शुरू करें. चले, लेट्स से 5 trials till 3 successes. Okay, let's do that. क्या पॉसिबिलिटी है पहले ट्रायल में? ऐसे फेल हो गए पहले में. Yeah. So if x is 5 and r is 3, then 5 trials में 3 successes आई. Yeah. So you could have f1, you fail the first one, then maybe you pass the second one, then you pass the third one, then you fail the fourth one, and आखिरी क्या होना चाहिए हमेशा?
Pass.
Pass. This is the key now. You can permute these as much as you like. ऐसे ही है ना? Combinations करते रहेंगे. इसको नहीं छेड़ सकते आप. नहीं छेड़ सकते. तो ये छेड़ेंगे x की वैल्यू चेंज हो जाएगी. Yes. So in effect, you are not allowed to touch the last one. So एक कम हो गया. That's what's happening. Okay. So combinations जिनके बन सकते हैं, they are one less than x. Is it x minus 1? Yes. R minus 1 options हैं. क्यों R minus 1? 3 सक्सेसेस होनी थी. आखिरी तो हमें पता है कि वो एंड में होनी है. उसके पास उसकी तो हमें गुंजाइश ही नहीं है उसको और उठा के कहीं उसके कॉम्बिनेशन चेंज करने की. So the total number we have that we can play with. अब आपका ये हो सकता है कि it becomes let's say P1, F2 and P3 and F4. इनके दरमियान you do all your combination, making sure there are 2 P's and 2 F's. That's all. लेकिन आखिरी को आप नहीं छेड़ सकते. So that's why this combination formula takes only x minus 1 total and r minus 1 total passes, because one pass is we know is in the end. So उसको गुंजाइश नहीं. Right. So फिर again nothing to memorize. Right. Makes perfect sense. और क्या होगा इसमें? Yeah. So what is the probability? It takes 3 trials, not more or less, to get first 2 successes. You can see 3 trials to get last one has to be success. Yeah. So if you do that, 2p square times 1 minus p, and you get the same answer using the formula. Now each of these distributions has its sample space, has its function, and then we can derive from it. I'm not calculating it here, but they have their mean and variance in terms of P, R, and whatever is needed here. So the mean of each and the variance of each is here. They have just calculated using brute forces the formula of mean. Yeah. So what's the formula of mean? For example, it is ex क्या था? Discrete case में xi f x I. ऐसे ही है ना? Now you know fxi, these things. Yes. xi are 0, 1, 2, 3 up to, and if you solve this, थोड़ी बहुत इसमें juggling करनी पड़ेगी, but you will come to this. Proof is not really part of this here, but it's good to know that then we extract the key information from each. Mean and variance of a binomial, this one. Notice that you can write those directly in terms of NP and R. Yeah. So आपको बार-बार calculate नहीं करना. Once you establish that my problem can be represented by a negative binomial distribution, these results become available to you. Use them. ये सिर्फ ये नहीं, और भी बहुत से results हैं by negative binomial की. Geometric distribution. Once you realize or you are able to show that my problem fits well in a geometric distribution, directly use all the results that are available for a geometric distribution. Right? Okay. Okay, I think we will do voice on next time. आज मैंने करना था discrete को खत्म, लेकिन maybe क्या थोड़ा सा है लेकिन I think काफ़ी we've seen a lot today, so that's enough. Yeah. Thank you so much. If you have any questions, as always, ask me now or later, email, visit, whatever you like. Okay? Thank you.